Hello, I'm Chris. Nice to see you again. And this is my new series of tutorial that I will show you how to use Arduino OPTA to create the PLC applications. But before we start, for the first step, I will give you some background about how the PLC is working and what kind of program language that you can choose to write a PLC program. Okay, I hope you will have fun with my video. Let's start. So, what is a PLC? What is operations? So before that, you have a PLC. In my tutorial, it is Arduino OPTA. Okay, so when the PLC, you collect all the input signals that you call using to sense the status of your machine or your robot. Something. It should be it may be a switch. It may be a temperature sensor. It also may be a proximity sensor. You have so many types of sensors that can collect some status of your machine. That you should also have outputs. What is your output? Outputs, and you need to control something. It can be a robot. It can be a motor, a LED signal tower. It's been anything you need to control. It will have output. So for basically, you will collect the data from the input signal like sensor and output the signal directly to the robot or motor from some relay contact. But in the industry work, they will also have a term called industry protocol. It may be both in that. It may be Autobus, Motorbus. It may be OPC-UA, EtherCAD, anything. There will be automatic exchange of input data and output data to add all these third-party device. The third-party device may be your drive, your robot, or just a LED tower, etc. So now you see it's a program turn here, right? So the PLC cycle would be to collect all the input signal and then write inside the PLC memory, and then to execute your program. And depends on your program, the logic that inside your program. Then you have some outputs, right? Then PLC will output all the signal after your execution of program is finished. Some PLC manufacturer will call this action like refresh. They refresh all the output. It means you refresh all the output to the robot or to the motor, something, to update the control status. So it will be continue like this, and just like a microcontroller, that one with a infinity loop. You can imagine it like this. And then how can you write a PLC program? There are 5 types of program language that is provided from IEC 6.1v13. It should be ladder, instruction list, function block diagram, physical function chart, and structure test. For the ladder is just a graphical program language that the programmer can read or write from top to down, from left to right. This type of graphical language is just like the electrical drawing. That's easy for the non-programmer to handle or to make the program. No, they don't need to have so much programming knowledge. And it's very famous in Japan or in Asia country. The second one is FBD. It's function block diagram. You can imagine a function block diagram in just like IC chip. Then you have so many AND gate, OR gate, or so many small function block. Then you can connect by the these input pins or output pins to write your logic. For some plan project or some simulation, some plan project, or depends on the end user, they request you to use FBD because it's easy to read, and you can, but you will not prefer to program very complex logic in one network. You make your program is not easy to readable. So the third one is instruction list, ILU. Instruction list is it's an assembly language. I think now you cannot see so much in the new PLC project, but for example, 30 years before, that you can find so many projects made by this instruction list. For example, like Siemens S5, S7, or some very old Mitsubishi PLC, they also need to write the program in this instruction list because they don't use so much memory. You can imagine that for some 30 years before, all the PLC, the memory is just counting in 1 kilobytes or something. They don't allow you to use so much memory, and this type of program language can save your memory. And this execution is very fast. But now you no need to care about. You need to care, but not like before. Don't to care so much about the memory or how the execution time of your PLC. But you need to, but not seriously than before. That's why the reason that why industrial list is now no people, not no people, just less than before to use this one, and it's not easy to debug. Then this one is SFC. This is very I think it's very nice program language because you can imagine this type of SFC is like a flowchart. Then the program will run from up to down, and then you see it depends on the trans. This trans is mean condition. They'll go to here or go to here, or n is n or n condition or o condition. It depends on your setting. They'll control your flow. And this is very easy to write the program. You can get the flowchart from the customer. You can just like draw like drawing, then to write your program. But this type of program, you maybe waste so much memory because at each step they will have their own status. For example, they have step, they will have their action, they will have their condition. So many things, they need to keep so many flags, so they may spend more memory. But it's easy to read because you actually can see what is your step now in graphic. So finally is SD. SD is something like high-level language, something like Pascal or like C or something, but not powerful than C, sure. And this type of language now, you can see there are so many European manufacturers like Beckhoff or Cookies or even Siemens. They also use SD as their example to teach you how to use their applications. But it should be depends on you. If you think SD is comfortable for you, you can use SD. If you think ladder is okay for you, you can use ladder, or you can mix. Before, I think more than 10 years before the PLC, maybe they cannot mix couple language in one program or one project, but now it's possible. For example, in this part, if you think SD is better for you, you can use SD. If you think this part is better to use SFC, you use SFC. You can mix both to one project. Okay, so before I start to play my Arduino PLC IDE tutorial, I would like you to download this software. There, I will paste a link in the video description, so please click on this link and download all these free software. The first one is Windows Arduino PLC IDE, and the second one is the PLC IDE tubes, and the third one is the Arduino IDE, the IDE software. If you download this free software and install your computer, you don't need to care about any driver. Then you should just connect your PC to your Arduino by using this Type C PLC, Type C USB, and can connect in one time. No need to search internet to face any trouble, because this software will install all the drivers that you need to connect to Arduino. Okay, so I hope you will have an Arduino and download all the software. Now we can start to make the program. Okay, so the first thing I will show you is here. I open the Arduino PLC IDE because I already installed in my computer. Okay, now the PLC IDE is start. Now the first thing I need to create my project. Go to Final, New Project, and just enter your name, my YouTube project, for example, just like. And then here, select the target for a new project. Make sure you are using OPTA 1.0 and then press OK. Okay, just wait a second. Now to be okay. Now you can see the project is created. And the first thing is you need to connect from your engineer tubes to the Arduino PLC. Here is a small connection button. Click it. Now it's uploading in process. Just wait a second. Okay, great. Now you see now it's connecting. And if it is your first time to use this CPU, please make sure to download or you press here to download your sketch to the PLC for the first setup and reinitializations. And after that, you can see status in here to be okay and what kind of interface is available in your CPU. In my case, because I just buy the chip one, so only Ethernet can be used in my PLC. But this is not a important thing. So the second thing I show here now is a different code. It means my project and the PLC and the project that inside my PLC is different. So the first thing I would like to download my first project to the Arduino. Go to Project tab. Then you see here it say main, global variables and task. Okay, so just drop here. Let's go open main. So main here you see there's a simple program. Count is equal to count is equal to count plus 1. It's a very simple program. Just count plus itself cycle by cycle. And so where is this count? Then there's a global values table. When you click the plus button, then you see count here. So it means that this CUT count is a global variables. And you can click the global variables. Then you can just right click and add any new variables that you need to use in your program. Okay, but in here, my first time, I would like to download it first. So I would like to save it first and then go to compile the PLC project. Okay, means you need to make sure there is no any error when you programming your project. I think it's not just Arduino or the PLC project. You need to compile first and make sure there's no error, and then do for example the compile process to compile your project to a machine code. Then the PLC can read and then download to the PLC. That's all the not just Arduino. For example, use Siemens, Beckhoff, Cookdisk, or Rockwell. Any PLC, they are using the same concept. One time you know how to use these more powerful tools, Arduino PLC IDE, you can use your concept to all other PLC. Not 100% the same, but the concept is very similar. Okay, now you see the compile is finished, no error. Then now I can download it. Before you download your project from PC to Arduino, the first thing you need to configure your connections. Go to online, set up communications. Then, because now I'm using USB, so I choose Modbus and go to properties and make sure you choose the correct port. Then you can check your port in the device manager. Okay, just okay, and then now I'm connecting it. Now I can download my project to my PLC. Go to online, download codes. Code is required, so all the retained and non-retained variables will be reset. Is okay? Yes. Okay, now your project is downloaded to PLC. Now you see the status change from different code to source okay. Now we can open the main program, our first program here. Then we can click on the live debug mode to see what is the variable now in your project. It is, I think, this is a function. All the PLC have this function, the live debug mode, something you call is online login connect to PLC. But all the function is same. Just monitor what is your variables value now. Just click it. Now you can see your count is always plusing. It means your PLC is running without any error. Done. But it's not funny. I will show you how to make some new program, but not use SD in this time. Okay, so let's go to your project, right click, add, new program. As I mentioned before, there's 5 types of language provided by IEC61113, right? There's IL, FBD, LD, SD, and SFC. For this time, I use FBD function block diagram. And then just to enter your name and deploy FBD. And here is a task. Task is assigned to, you can assign to fast task, the slow task, background task, or initialization task. In my case, I use fast task. And just press OK. Then you may ask, what is the fast task? Then here is a task, item called task, right? Just click it. Then you see what is your task in here. You have fast, you have slow, you have background, you have initialize, and the period is 10 milliseconds, 100 milliseconds, and 500 milliseconds. So it depends on your applications. You can assign different programs to different tasks. Not all tasks need to be assigned to a fast. Not all the program need to assign to a fast task. For example, maybe you like to write some value as CSV file to some file system. So you don't need to run it in any 10 milliseconds to check your flag. You need to write it now or not. You can check it from 500 milliseconds. 500 milliseconds in the background task or slow task at 100 milliseconds. It depends on what is your task, what is your application, and what is your goal. Then you can either assign your task to different program to different tasks. Okay, so here is your edit now. Here is your FBD program here. The first thing I will show you is I add a AND logic in here. Go to operator and operators and blocks. Go to, I think it's logic. Yes, and here is AND, NOT, OR, and exclusive OR. The first thing I'll use an AND logic. So what you go here, just click it and drop to here. Okay, now you see AND block is clicking here. Then you can assign all the pin here. For example, I will assign some local variables. In my case, local variable is some variables that can only use inside your point but cannot use outside, I hope. Because some PLC maker can still allow you to directly access the local variables in other place. Anyway, okay, so I'll show you how to add a local variables. Thus here you have a table view and you have a text view. I will show you how to use the table view first. So go table is right click, insert. Then a new variables is created in your system. So all the PLC program you need to assign the name and the type, and at least you need to assign these two settings. So here I use B1. Assign it as a bool data type. This is a 1B data. And I will add one more, just B2, also a bool type. And then I will save it. And while you change to the text view, then here is the IEC format. How to define the variables inside your program. You can define the table your variables inside the var and between var and var. So for example, here I just told B3, bool, B4, and also bool. And then save it. Go back to the table view. Then you see the same. You are doing the same things. Okay, after we define the variables, now we can assign the variables to our end block. You have so many levels. For example, you can just select here, drop here, And then, for example, now if B1 and B2 both is in true conditions, I will output B3. It's just like the very simple logic. And then I will compile my project again and save it and download the project and click online again. Now you can see here false, false, false. Because we don't have any initialized value, so the default value should be false. Now we can just double click here. You can directly change the value of your variables to any values. In my case, for example, I can change it to false or true, and just +1. Then we change to true, right? Let's do the same thing for the B2. You can also +1 here. Then you can say B4 will be true. It's very simple logic. Then it is your first PLC program. Then you can just change it back to 0. Then the output will be false. Great. Okay, so for example, there is some case that you not just have 2 conditions, you have so many conditions. So we can just go to here, right click, and there is a increase pins. Then you have 1 more pins, go to here. You can just assign, for example, in my case, B4. Okay. Then now it means B1, B2, B4, both in true conditions. Then B3 will be on. Let's compile again and download the code to the PLC and monitor it. And if I just turn on B1 and B2 and also B4, then same result, B3 will be true. But okay, then next one I'll show is how to use the NOT logic. For example, here B4, right? You can right click here. I think they don't have here, right? Okay, you have here, then you just drop a NOT in here, and I will delete this one. Just copy in here. Okay, oops, and I will drop in here. You can drop in here. Okay. So you can go to add a new network beside here, top, and I'll move my N here. You can just delete one, delete here, and go back to here. This drop is more easy to see. Okay. And just delete this one, okay? Oops. And just delete this pin again. Delete pins. And then error is I don't know, something is error here. Some errors happen. Don't worry. Open again. Okay, open the project that I created before. I think it's my YouTube project. Go back to project, and here I can just add one more time. Click here, 0001, and new network top, and then add a NOT logic in here. Group operation and blocks, logic NOT, and drop B4 in here, and then add a new variable called B4 invert. Okay, then just drop here. So add a new more pin here. Oops, and drop in here. Great. So compile your project, make sure no error, and then connect to PLC. Finally, download the project again. Okay. Now you can see, because it's true in here, you invert your logic, so that'll be false, right? I change it to false. You see now will be this B4 inverter will be true. So you're done. This is your first logic. If not, So for next one, I'll show you how to use the OR logic. The same, you can just for example, I delete this one, and I drop it OR logic in here, and there's something I just drop in here. Now all the result of AND logic will be as the input of OR logic in here now. So, and here I just yes, before I'm not using anymore, I can delete it, and just insert one more B5, and here one more pin called B6. Okay, so I will input B5 in here, and or B6, then finally I will output the B3. Okay, now the logic will be if B1, B2, B4, and B3 or B6 is true, then B3 will be true. Compile your code and download the PLC. Go to monitor. I will just turn on B6. Now you can see B3 will be on because there's an AND logic in here. Then if I turn on the B4 and B5, now you can see B3 also been true. Okay, now your project, your program is done. The next one I'll show you is differential up, or I'll show you how to use the plus the add value or declaration first. Just add a new network bottom, and go to this folder. You have some correlation, for example, plus, minus, or log, or more, so many functions here. The first I'll show you is add. I just show you add in here, drop in here. Then you can see there is a 2 value input and 1 output. So I can just insert it. I will choose int. I just go to checkbox and choose the data type here. I choose integer in here. Okay, I don't know why, but integer, and for example, my integer 1. Then I just drop my integer 1 in here, and then here I would like the plus 1. Let's right click it. Here, right click it. That way. I don't know why I don't have here. Okay. Okay, here, new object, add a constant. Just drop here, and then just enter your value. I choose 1 here, and then we'll go back to my integer 1, and then download the project again. And go to live online. You'll see this program is exactly same as what you run in main count equal to count plus 1. Okay, the question is, I don't want it to count in each cycle. I just want it to count in some conditions. How can I do it? You can use jump or you can jump or break or some status control to implement your functions. But your features, but there is a very a very common way that use a PLC with IC61131. It is a EN and ENO pins. You can just right click here. Then you can see here is enable EN and ENO pins. So after you choose these options, that you see EN and ENO in here. So what is EN and what is ENO? EN is mean if this condition, the input of EN is become the true, then your block will execute. The program will be run inside of your will run the block. But if your EN is false, it means that your program will not run here. So it means that if my EN in here is true, the add block will be run. So my integer will be plus 1 to each cycle. If EN is equal to false, so it means that my int will not plus itself anymore. And for ENO, maybe you use some some specs of some functions or function blocks sometimes. You can use ENO to know your function or function block is executed without any error or not. But it depends on the menu or the type of functions. But you can just if the ENO is equal to true, it means that your block is executed in the end and without any error. If your ENO is false, it means that your ENO is your output ENO has your block have some problem that you need to modify your program or your parameters to make sure you pass all property parameter inside your block. Okay, so in here I will just drop B3 in here. So if B3 is on, now if B3 is on, then the integer, my integer, will plus itself in 1. Just compile your code and download it again. Great. And go to plus. Now when I just turn off B3, just turn off here. Okay. Now you see the function, the add block will not be executed anymore. Then my integer 1 will not plus itself anymore, right? So if I turn on B3 again, B3 again, then my integer will execute again. So I think you make sure, I think you know what is the function of EN and ENO. It is very useful when you create your program in FBD or in ladder. Because in the ST, you can use if case to control your program flow. But for the FBD or ladder, it may be a little bit difficult, okay? So it does not add. For example, when I drop a sine function, I need to disconnect it again. Disconnect it first. For example, when I drop a sine here, you can also add a enable flag in here. If you don't want to use, you can just disable it. Okay. Okay, the next one I'll show you is differential up. It means the program will detect a signal from false or true. It's very common when you use in the PLC work. For example, some options or some commands will be only run from a signal that from false status to true status, or from true status, or from false to true, and then get back to false again. It depends on what kind of application or what kind of drive that you're using. For example, if you're using Siemens, actually there's Sabo on some. If you're Siemens, you're using the function block. So some for the S120 drive, their servo on signal is only accept a false to true raise up. So let me show you how to create a differential up, a gauge up actions. So the add new network after, and just close here. Go to standard and gauge detections, and there's a R detect and F detect. R detect means detect a signal from false to true, and F trick is detect a signal from true to false. So I just use R TRG and drop here. Then you need to insert a instant name. So don't worry, I will explain the function block or something in the future. So now you can just now just images is you need to give it available a memory for this block to work. For example, just choose my detect 1. Okay, now here is a differential a gauge up detection function block is inserted in your project. So what I do, I will just go to B3 and drop in here and add one more variables called B3 gauge up, and then drop it here again. Okay, probably here I will not use B3 anymore. You can delete it. Just right click, new object. This time I will choose variables and double click it as B3 gauge up here. Double click it. Okay. Now function program is done. Compile it and download, connect, download again. Okay. Now you can go to monitor. Now the value I come back to say it back to 0 because minus not equal to C. Now, although now we see here the PV is true, but the output is false, right? It means that if you detect a PV from false to true and then PV gauge up will be on in one cycle only. So when I just turn off the B5, okay, and then turn on the B5 again, then my integer will plus 1, which is only but not plus forever because PV gauge up is only turned on in one cycle. This very useful function you use it so many times in the future when you create your own PLC project. Okay, and then finally I will show one more function. It is called move. It's also a very basic function. You use it more than 1,000 times in the future. Just add a new network bottom. Okay, so go to drop a move function here. I think where's the move? I also forget it. Yes, here. I think here. Yeah, there's a move block that drop here. And then same, you can enable the ENE PO fac, and then I will use B3 B gauge up. B3 is okay, right? B3, then B3 is on. Then I will maybe I can reset my initial one. Just go to here. I think here. Okay, here, and then go to add a constant. Okay, constant, move 0. Go back to my initial one. Okay, and then compile it and connect it. Finally, you can download it. Okay, now you can see value will be okay. Let me order it. Now you can see it will be false. So although I think B3 is not a good choice. B3 is not equal to C. I think okay, better to create one more variables. B reset. ESET. And then drop it, save in my project. And drop here to here. B reset. Okay. Oops, should not be there. Delete it. Use B reset. Okay. Compile and connect. Download. Monitor. Okay. Now, for example, here I can just pass it to 1 by use set to false and then set to true. Now you see this be 1, right? But if I plus the B reset to true, then the 0 will be moved back to my initial one. So this is the move function running. I think this tutorial is enough. So for the future, I will show you how to use the function block, how to use function, how to use more instruction inside the library, and also how to show you how to configure the modbus TCP and just integrate with some factory automation device in the future. So sorry that my tutorial is being too long. I hope I can see you next time. And if you like the video, please press like and share to any PLC program or other program that you would like to use Arduino OPTA, because it is really a very good engineer tubes. That's what I'm feeling. Okay, so I don't want to waste you so much time, and see you in the next video. Bye bye.